Okay, IP address is the one which we use to identify device. So there is a need for an address to identify device. That address need to be big because we have a big network. But the problem is the IPv4 version that we have is not that big. It's only 32 bits. So this cannot support more than like 6 million device. But if you take the population of the world, it's very small. This number of IP address is very small. Okay, so this 32-bit IP address, which we are still using it actually. Not everyone has migrated to IPv6, though there are many companies already migrated, but most of the companies have not it. Most of the ISPs have done it, but not most of the enterprises have done this. Some ISPs are yet to do migrate to IPv6. So we have to seriously take into account and migrate very soon. Only then we can reach the rest of the networks, and we can have entire service. Today everything is in the network. If someone takes the cell phone from me, I'm done. I'm finished. Because everything we do through networking, we use cell phone, we use laptop to communicate. It has become part of our life. But new technologies that are emerging day to day, they don't have enough IP address now. They say today in news that shortly there are going to be guests from other planets, and they're going to bring up a lot of technologies into the world, and which is going to make the revolution in IT world. I'm not telling joke. I'm telling exactly what the news says. There are aliens who is going to visit our planet this month. Not this month, December 8th, I think, something this. And they're going to change the IT world. So those things need big IP space, IP address. That's why they came up with 128-bit size IPv6 address. So last time when the alien met that one particular genius on the earth, that alien said, your 32-bit is not enough. If I need to deploy this technology in your earth, so keep your network ready for bigger technology. And the alien left. And again, that alien is going to come this December 8th. That's the prediction in Satyam News today. You can watch in YouTube. They say they are going to visit. So now the earth is ready with this 128-bit address, IPv6 address, for those new technology that is going to be introduced this year itself. I'm not telling story, I'm telling you the real truth. So 128-bit address is so important because we don't have IPv4 address anything left. There's no address left. There's no address left. So you need 128-bit address, IPv6 address, so that you can have enough of IP addresses for communication. Now, enough of IP addresses, how much? You just take on calculator and say 2 to the power of 20, 128. That will be very big number, that much. Two to the power of 128. You see the number size? Plus 38 here. E plus 38. It's a very big number, okay. So someone said like this: every single person on earth can have 10 to the power of 7 public IP address. So Joseph can have 10 to the power of 7 public IP address. Arindram can have 10 to the power of 7 IP address. And that too, they're all public IP addresses. And still, you will not. You will have much more left. Every person on earth can have these many public IP addresses. If that is the case, then is there need for any private IP address? No. The reason why we had private IP address in IPv4 is to manage with 32-bit. But now you don't need to manage because IPv6 is very big. You don't need to manage. Yeah, so IPv6 is very big for the human beings. You have too much. So there is no private address concept in IPv6. One thing I have made it clear. What? We have enough of IP address and there won't be need for private IP address. Which means every device on the earth is going to be public. See, I'm not including aliens, I'm not including robots in this. For a human being, this is too much, 10 to the power of 7 per person. And someone said like this: every square feet of earth can be given one IPv6 address, public IPv6 address. Every square feet. It includes mountains, desert, ocean, everything on the earth. Every single square feet can be given an IPv6 address, which means you can control the entire earth from one place. Because every square feet can be given one IP. Today I also saw in a news that robots are giving birth to robots. Yes, I'm not joking. I'm very serious. Robots give birth to another robot. See, we human being reproduce. But they have found something that robots also can reproduce. Now those robots are in a microscopic size today. The scientists have developed. And they can make it at any time macro, bigger. Today news I am talking, Satyam News. very small cells from a frog from Africa they have taken, and it's a brain cell as well as the skin cell they have taken, and they have created robots. And inside the water, these robots start multiplying. Who knows? Tomorrow they will fix one machine inside, a computer inside this robot, and give an IP address, and these robots will be sitting on every square feet of the earth, monitoring everything, monitoring the climate, monitoring the temperature. If some place is too cold, these robots will say, hey, this place is too cold. Sun, you come here. Make this place hot, and sun will come here. China has made an artificial sun. You might have heard that long back. And that sun will come. You don't need to wait for the natural sun. I don't think Arindaram and I don't know about Arindaram. I don't think Joseph in this class is eating chicken from a farm. He is eating from the KFC kind of shop burger, packaged, grinded food. Indians, we cut chicken and we eat. But most of the grown-up countries, they don't cut chicken and eat. They always use the preservative food, preserved and modified food for their daily living. Most of the countries. So already they are not having anything natural, direct. So sun is also going to be not nature in future. Who knows? Man is mad. They'll spoil the nature and they'll create another one. And they will boast themselves. So for all this, network is very important, you understand. If you want the artificial sun to come to your place from somewhere, you need a robot sitting in a cold place sending a signal to the sun. Sun, come here. It is very cold in Bangalore. Sun will come in the middle of the night, 2 o'clock, and make this place bright and hot. I don't know. I'm just imagining a small trainer here. These people with the evil mind, they all mad mind. They always think this type of mad things. That's why aliens are invading India. Sorry, not India, the world. That's why they create this robot. Who wants this robot? They have created this robot which can multiply. I don't know. The consequence may be very serious. Maybe after 10 years or 20 years or maybe after 100 years. The consequence is going to be very bad. For all this, IP address is the power, connecting point, ID. So coming straight to the point now, we'll not have any more stories. IPv6 is 128. Don't think, in this world, if someone is doing something good for you. No, everyone is doing bad for others. IT is also like that. Don't think, this internet is for the human being to use. No. No. Today you are using. And we are all getting into the trap. And someone who introduced this trap will one day come and harvest everything. Yeah. If they ban apps, what will happen? If some company wants to stop riots, what they do, they immediately cut the internet so that the news won't spread and more people won't come and participate in the riot. If this can be done, they can also cut all the communication that you currently have and demand you something very big if you want it. For that, big network and the address to support that network is necessary. This 128 bit is written in 32 hexabit. So what is the size of an IPv6 address? It is 32-bit hexa or 128-bit binary. Anything you can say. But mostly people will say IPv6 is 128-bit binary. You can also say there's nothing wrong. IPv6 is 32-bit hexa. How 32-bit hexa? You see, 128 divided by 4 is 32. Why I'm dividing by 4? Because one hexa bit, which is F, is equal to 8 plus 4 plus 2 plus 1. How many bits? This is also 15, this is also 15. So 1 bit of hexa is equal to 4 bit of binary. If anyone didn't understand this, let me know. Do you understand? Anyone didn't understand?
Yes.
You understood? Okay. Thank you. Mute. Thank you. So 1 bit of hexa equal to 4 bit of binary. Then if I need to write the binary 128, I have to divide it by 4, I get 32. Now what is the size of IPv4 address? That is also 32, but the number system is not hexa 32. IPv4 is binary 32. See, there is some sort of connection, from IPv6 and IPv4. Here also 32, you see, there also you will see 32. Okay, now here also you will see another connection, 8. There in IPv4, each octet is 8 bit. Here also you have 8, but it is called hexadate. Hexadate, meaning 16 bit of binary. See, I told you 4 binary is 1 hexa. See, this is 1 hexa, this is another hexa, another hexa, another hexa. Totally how many bits? 16 bits, right? 16 multiplied by 8 is what? 128. Or if you take if you take in hexa, 4 multiplied by 8 is what? Sorry, 4 multiplied by 4. So I should not calculate like that. 16 only. So yeah, that's correct. 4 multiplied by 8 is what? 32. So this is hexa and this is binary. This 4 hexa bit is equal to 16 binary bits. If you want to calculate in binary, then you multiply 16 by 8. If you want to calculate in hexa, 4 multiplied by 8. So what I'm coming to say is, you also have 8 in IPv6, but here 8 hexadate means 8 sets of 16 bit. 8 sets of 16 bit, like this. Wait. Colon 1111 colon 11 colon 111 colon 111 colon 111 colon 1 2 3 4 5 6 7 8. Okay, 8 sets of 16-bit. This is the size of IPv6 address. This is how IPv6 address is written with a colon. Every 16-bit is separated by colon. All right, it is separated by colon. Fine. Next is, if IPv6 is 128 bit, then won't that be taking much time for getting processed? If it is 32-bit, definitely, there is some time taken. 128-bit, the time taken must be more. In IPv4, you got only 32-bit source IP address and 32-bit destination IP address, isn't it? Here, you're going to have 128-bit source IP address, 128-bit destination IP address. Won't this be too long for processing? Answer is, yeah, to process the address it will take time, but to process the IPv4 header and IPv6 header, as a whole, the whole header, IPv6 header will take less time. Even though the IP address is long, like 128-bit source address, 128-bit destination address. Here, 32-bit source address, 32-bit destination address. Even though there is some extra process time taken to process the IPv6 addresses, but the header, when you compare the timing that is taken to process IPv4 header and IPv6 header, when you compare this time, IPv6 header is less time taken to get processed. Less time taken to get processed. IPv6 header is less time taken compared to IPv4. Because the header is a simplified header. IPv6 header is a simplified header, meaning you will have only reasonable, necessary field in the header. Whereas IPv4 header will have always all the fields, even if you are not using all of them, those fields will be having some junk value as a bits and bytes and kilobytes sometime. And every packet, when they go to the router needs to read every single field of a layer 3 header. If it is IPv4, there will be too many headers. After reading the too many header, it may be knowing only one or two information, like what is the destination IP and what is the time to read. All other things are least bothered about the router. The router won't care about it. But it has to read the entire header. In order to know the destination, please understand I'm repeating. IPv4 header is like an goods train in India. Goods train. Chikabuku, 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 chikabuku. The goods train, will have a lot of boxes for the goods. Now, these boxes are hooked to the engine. Some boxes may have some goods. Some may not have. But every time, whether there is some goods or not, if the engine will be keep on pulling the boxes, then the energy consumed and time taken by the engine to pull will be more, correct? Because the box is also heavy, it is not 1 kg or 2 kg, it will be tons of kilogram. The wheels, have you seen the train wheels? Very big and very heavy, made of only iron, not with the tire, rubber. So there is a goods train, and you got boxes hooked to this. Many boxes are hooked to the engine. Even though only this is full, these boxes are simply there, always connected. This is how IPv4 is. You have many field, and all the field will be always there, even if you don't use it, even if you don't want it. Because it is there, every router will see what is inside, check thoroughly, is there anything inside? No. Check thoroughly, is there anything inside? No. Check thoroughly, is there anything important inside? No, everything is just, but unnecessarily time wasted. Whereas IPv6 will detach this. Hey, I don't have anything to put in this field, so let me not have those fields. IPv6 will have only those fields that are really necessary. Now this engine can go very fast because it has got less load. IPv6 headers are expandable. You can extend it whenever you want some new protocol support in the packet. It can be extended. All right. So IPv6 header is simplified, and if you need some extra service, only then you will add the necessary field so that you can have that extra thing inside. If it is not needed, then you simply remove it. In that way you can save power. So IPv4 header is always having all those boxes, even if there is no important information, which is going to take more time for the devices in the middle to process. Whereas IPv6 headers are simplified, even though IPv6 address is big, but the header as a whole is very simple compared to IPv4. And whenever you need some additional service, you can extend it. Say for example, you are enabling OSPF, so OSPF needs to send hello packets. So OSPF works in layer 3, you all know, IP89. So what it does, IPv6 header will add the field for IP89. Whereas in IPv4, you always have the protocol field, whether you have a routing protocol there or not, the protocol field will be always there and every device will always process it. All right. So IPv6 is simplified. IPv6 is faster than IPv4. So one advantage of IPv6 we have learned. Now, before we learn the other advantages, I would like to talk something more about this 128. IPv6 is 128-bit, that is right. But will that not be a difficult task for you to type the IPv6 address? See, earlier you were having like 10.23.41.53. You somehow managed to remember this address because it is just for number 10, 23, 41, 53. 10, 23, 41, 53. It was easy for you to remember. It was easy for you to remember in IPv4. But in IPv6, you are going to have 128, which means there will be 32 numbers. This is all not going to be 1111. It's alphanumeric, I told you. So you will have IP addresses like 2345 colon 1289 colon A1 B2 colon K1 no K and all. F is the biggest number in alphanumeric in hexa. So C238 colon. So are we going to remember this type of number? I know it will be challenging, but I'll tell you, you can shrink, you can write a small number that will get expanded to big number. How? Let's see. If you have like 2000 colon 0000 colon 0000 colon 0000 colon 0000 colon 0000 colon 0001, you don't need to type these many zeros. Say I forgot one more 0001. You don't need to write all these big numbers. You don't need to type these many zeros and colons on your computer. You can simply type by omitting this like this 2000 colon. Instead of this, I'm writing this. And then this leading zeros can be omitted. 1 colon 1. That's all. This is equal to this. Both are same. So when you type this to a computer knows that this is an IPv6 address and there should be 8 hectate. 1 is here, 2, 3. So how many left? 5. So it will automatically fill 5 hectates of 0. See? 1, 2, 3, 4, 5. 5 hectates of hexadates of 0. So you don't need to really type this big number and colons. Not necessary.
Sir,
You simply,
there is no any subnet mask, anything, huh? Nothing.
I'll talk about that. I'm coming there. I appreciate the question. Right? So I'll give you one small work. Now take your pen and paper. 2000 colon 0000 colon 0000 colon 00 colon 0 A B C colon 0000 colon 0000 colon 0002. How you will shrink it? Do it with your own imagination. Don't tell to me. Write down. It's a turn for Arindram. Tell me how you will write it in a simple way.
This is 2000 colon again colon colon
Colon
colon again colon ABC colon colon 2.
Okay, mute please. Mute.
Sir.
Okay. Now, you see, this is not correct. Why you know? We cannot repeat this twice. It's okay, nothing wrong in doing wrong. I did not teach you, so I'm trying to teach you with the answer that you have given. So now if I say this is wrong, then you understand, oh, something is wrong, let me listen to him. So you are listening now. I'm telling you, if you're putting colon colon, you should not put more than once. It's only once.
Okay. Okay, sir.
Why you know? The device that you configure this will be in confusion. How many hexadecides totally? 8 hexadecides. How many are already there? Only 3 is there. So how many balance? 5. This 5, here it can be 4, it can be 1. But the reality is not 4, it is only 3. Here it can be 2, and here it can be 3. But in reality it is not 2, it is 3 here. Or here it can be 3 and 2 here, which is matching to 1. So, but the device cannot guess like this. So if you do only once, so how you should write? What is the right answer? The right answer is 2000 colon ABC colon, see now I'm writing this one, 0, and then this one, 0, and then 2. This is the right answer. So that device now it knows 1, 2, 3, 4, 5 is already there, and balance is 3. 3 hexadecides of 0. It's matching. Yeah. So leading zeros you can omit. This 0 you should not omit. Why? If you cut this 0, it becomes 2, not 2000. But if you cut this 0, it is only 2. It is always 2, even if you cut the zeros.
Sir?
All right.
Hello?
Yes, sir.
Sir, colon, 2 colon, going to explain.
2 colon is for continuous zeros. But you should not do twice. You should do only once. If you still have question, ask.
Sir, 2000 colon. I think extra, the one more octet also 0 means how come we will be asking that colon, sir? Only 2 colon?
Yeah. What you are saying is 2000 colon 0000 colon 0000 colon 0000. This is what I have. Now you're asking me to add one more. Okay. and then 0 A B C D colon, sorry, 0 A B 0 colon 0000 colon 0001. Okay, is this your question?
Yes, sir.
Okay, same answer. 2000 colon. For all this, I'll put the consecutive zero only you should put, okay? Colon colon. And then this zero has got no value, so I'll put AB0 colon. Instead of this, I'll write just only 10 and I'll cut this one off and then I'll put only 1. This is the right answer for this one.
Sir, the now first and last octet only the value. Then how come?
தலைவா நீங்க தமிழ்ல சொல்லுங்க தலைவா என்ன சொல்லுங்க சொல்லுங்க
சார் ஃபர்ஸ்ட் லாஸ்ட் வந்து ஒரு வேல்யூ வருதுன்னா எப்படி சார் ரெண்டாவது இது பண்ண முடியும் எத்தனை செமிகோலன் 2000 வருதுல சார் 2000 லாஸ்ட் வேல்யூ இருக்குல்ல சார் 2000 கடைசி ஆக்டேட்ல வந்து வேல்யூ இருக்குல்ல சார் 1 அது மட்டும்
Okay, I'll tell you. His question is, here you are writing 2000 same like this, then why you are writing 1 here? Why not 0001? Correct?
Yes, sir.
Sir, okay, see, I'm repeating is.
Sir, ஒன்னு மட்டும் இருந்துச்சுன்னா அதை எப்படி சார் சிம்பிளிஃபை பண்ணணும் அது நம்ம ஃபர்ஸ்ட் 2000 ஓகே லாஸ்ட் வேல்யூ ஒன்னு மட்டும் இருக்கு அதை எப்படி சிம்பிளிஃபை பண்ணணும்
ஒன்னு மட்டும் இருந்தா ஒன்னு மட்டும் போடுங்க. If you don't have 0001, I don't understand.
Sir, 2000 colon 1 is correct?
Okay, that we already wrote no here. So here you are saying 0. Yeah, 2000 colon 1. colon 1. This is what your question, right? என்ன தலைவரே இப்படி அமைதியா இருந்தா இப்படி கேள்வி கேட்டு மத்தவங்க வெயிட் பண்றாங்க இல்லையா
சார் எஸ்
ஓகே thank you fine so we have learned how to simplify an address and write it so that it will be easy for you to handle. So IPv6 is not difficult. That's one thing you need to know. Second, your IPv6 address, that 128-bit, is equally divided into 2 halves, which means you got 64 bits colon 64 bits. 64 bits colon 64 bits. And this 64 bit is what the network portion, and this is what the host portion. But the network portion, we don't call it as network portion. For your understanding, I say because in IPv4 we use this terminologies: network, host ID, network ID. But in IPv6 language, this portion is called as global. Instead of saying network ID, you'll say global ID. Here, instead of saying host ID or host IP address, host ID or host bits, here you will say interface bits or interface ID. Yeah. So IPv6 is global ID 64 colon interface ID 64. Now, if someone gives you an address for your computer, it will be like this only. What? 2000:1/64. Just for example, I'm writing. So this is how they will give you, meaning first 64-bit will be networking. And the last 64-bit will be the ID for that host. Okay, so the mask 64 will not be seen in a core network. That /64 is for the end device, for the end user. But if you take an organization, there are many departments. For each department, you want different network. In IPv4 world, we used to say subnets, subnetting. You don't have subnetting here, but there we used to have subnetting, no? Subnets, multiple subnets. So how the network given to a company? For individual, this is how they will give. For a company, they will give like this: 2000:/48. If it's a very big ISP, they will give you like this. To the ISP, to the ISP, they will give like this. Or to a big company, they will give like this. What does this mean? It means that 2000:00:00:000. This is what the network portion is. 16-bit plus 16 bits plus 16 bits. If you add, you will get 48. So up to here, they have masked. Now you are free to use the next 16-bit and have subnetting like this. They give you up to 48. Now what you can do, you can take this, and for the first department, you will say 2000:1:1/64. This is for the first department. See, 64, this is 48. 64 means it includes this one. You are masked up to here. But when they give you, they masked only up to here. And they give you, they masked only up to here. But by adding just one bit, see how the subnetting is very easy in IPv6. You got the 16 bits for you to increase the bits and get new subnets and put the mask correctly here. 2000:0:0:2. This is another subnet. First IP in that department. This is first IP in this department. 64. Likewise, you can keep incrementing until it goes as F, which means 15 subnets. And then you can go to the next bit, another 15 subnet. In each 15 subnet, 15 subnets. When it is full FF, then you can go 100. It means you will get like 65,000. These many subnets. Sorry, not here. Not here. This is the update. This is the update. They have allowed you to use this 4 hexabit, which is 16 binary bit, to do subnetting, so that you can get 64. So you can have in your office up to 65535 or 36 subnets from each network that you get from ISP. if it is 48-bit given by your upstream ISP, you can make it as 64 by doing subnetting, by adding bits in the fourth hexadate. How many subnets you can have? It is 2 to the power of 16 because you got 16 bits. You understood? Subnetting is not that difficult. More about this is coming later. But one thing I want to tell you, IPv6 learning is more easier than IPv4. In IPv4 to learn subnetting, you spend a lot of time. See, we have finished subnetting. You need to simply increase those bits in the fourth hexadecimal to get new subnets. So when a company receives a network from the ISP, they will not give you 64, they will give you less than 64, like as I taken here example 48. So that whatever is between that 48 and 64, that many bits, you can use it for subnetting. Next, the advantage of IPv6, one we already saw, it is fast. It is fast, and then less process consumed. It is all because of simplified header. Now, second advantage what I want to say is, if you want to protect your data from getting stolen, you have an inbuilt IPsec. IPsec is inbuilt, meaning you need to simply do extension to the IPv6 header. I told you IPv6 header is extendable. IPv4 header is not extendable. As a result, you need to add an additional layer of IPsec for protection. Additional layer. Where in IPv4 you used to add ESP header, additional header. Whereas in IPv6 you have extendable header. As a result, you don't need to have a new layer of IPsec. You can simply have IPsec in the same layer 3 header as a field. Yeah.